Good afternoon, everyone. Hope you're having a fantastic start to your weekend. Bit of housekeeping before we get going. Sudo Kevin AF, thank you so much for your sub. I really appreciate your support. So the previous stream we did, I finally, after years of not streaming, unlocked a shiny sub button below. So if you're watching on Twitch, there's a few new things that means for us. There's a sub button below if you'd like to show your support. Of course, there is absolutely never an obligation to do so. Everything I put out will be free here and free on YouTube. But if you'd like to join the Hacker House, there's a sub button below, and your support would be not required, but very much appreciated. It also means I have to start running ads, boo. So I'm going to keep those to only when I go on break. So when I go on break, I'll be chucking up some ads to keep Twitch off my back. So I hope you don't mind those, but they'll never interrupt the content. And I think that's about all the differences. And there's like bits and stuff. I don't know. We'll figure it all out as we go along, hey? But yeah, Sudo Kevin AF, thank you so much for your support. Some more housekeeping. I'm feeling a little bit under the weather today. So we're going to just have to see how we go with this stream. If we have to pull up early, we have to pull up early. It is what it is. But I wanted to have a crack at this anyway. Because, well, what are we doing? First of all, we're working through the Cryptopals crypto series where we build various crypto primitives and then break them and whatnot. Menstrual wise that maybe I went out last night, maybe it's self-inflicted. Who knows? Who could remember? Working through the Cryptopals series where we kind of build crypto stuff and then break it. Last stream we worked on, yeah, shut up Menstrual, you knew, you jerk. Last stream we worked on ECB cut and paste. And for those who were here, you might recall we felt like we painted ourselves into a bit of a corner and gave ourselves an unexploitable challenge. If you didn't catch last stream, all the streams, previous streams for this series are on YouTube. For Twitch, there's a link down below somewhere. If you are watching from YouTube, hello to you. Hope you're having a fantastic day. We thought we'd given ourselves an impossible challenge. And I was editing the video. I'm still working through that, so that'll be up in the coming days. But I was editing that video, watching myself believe that the challenge was unexploitable, and I think I saw how to do it. So what we're going to do today is we're going to revisit ECB cut and paste, switch it back to hard mode, and see if it's doable. Very well might not be, but watching the video as I was editing it, I was like, I can't not try this. So let's see if we can make ECB cut and paste hard again. And then I'm going to walk through what I think I was seeing and thinking during editing, and we'll see if we can get it done. ReefBR subscribed. Thank you so much for your support. I really appreciate it. Oh yeah, that's the other thing. If you've got Amazon Prime and you link your Twitch account with Amazon, you get a free sub. And you should use that to support any of the streamers you watch, because what you're doing is you're taking money out of Jeff Bezos' pocket and putting it into those of streamers, which I can't think of a better thing to do. So if you've got Amazon Prime, then there's a free sub waiting for you. Make sure you don't let it go to waste. Alrighty. So here's what we did last stream. It was in our URL encoding. So you know what? Let's do this. Let's have a quick play. Let's comment out all this here, and let's do the profile to QS, email to QS. Yeah, this here. So we give it an email of foo@bar.com. Let's print that. All well and good. But we thought we needed to bring special characters to the party. And by special characters, I mean unprintable characters. Things like HexoB. Alright, so if we run this, you'll see that we've got HexoB raw in that query string. And we thought we needed that to win. And so what we did was we basically told Python's URL encode, hey, don't bother percent encoding bullshit characters. Ampersand and equal, yeah, sure, percent encode those, because the challenge specifically called out that our solution should not allow an attacker to bring an ampersand or an equals to the party. So we blocked those, we banned those, but all the other unprintables, we were like, don't hex encode it, right? So we just duplicate this line here. Actually, you know what? Let's not. Let's add a switch here to this function. Hard mode boolean will default to false. And down here, if hard mode, else, cool. So this function with hard mode set to false, which is the default, the previous behavior will light up. Let's get rid of all of this safe carve out we gave ourselves. So that's fine. We'll duplicate this line, and for the second one, we'll turn on hard mode and run it. So first of all, the differences. You'll see that @ becomes percent encoded under the hard mode, but also this hexob, which used to come out raw as like a vertical tab or whatever hexob is, becomes %ob. And we thought that made the challenge unexploitable, but I think we can do it now. So let's set up the sketching we were doing at the time we decided it was unwinnable. So I want a pipe, and then I want 15 spaces. Let's just check this is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. New block. Cool. So these, the pipe represents the first character of a block, and then the spaces are the rest of the block. And then again, we get a new block and a new block. So when the code encrypts these query strings, what's it going to look like? It's going to look like this. Email equals, and let's just, to keep things simple, not bring any ats to the party just yet, because that throws off our alignment. So email equals foo, and uid equals 10, and role equals user. And the goal here is to do an ECB cut and paste attack to cause the oracle to give us some ciphertext, and then we kind of do some switcheroos on some blocks and end up with role equals admin somewhere in the ciphertext that will then be decrypted and parsed, and we win. So the goal is to get role equals admin somewhere, but of course, as an attacker to the oracle, we can only give email address values. And we were thinking stuff like this last stream. We were thinking we can do stuff like email equals, and then a bunch of don't want that at there. That should be ampersand. Ampersand, good. We were thinking we can do tricks like a whole bunch of spaces for the email, and kick off a new block with whatever we want. AAA, BBBB, CCC, whatever. And we were like, can we do things like have this block like end with the word roll? That looks good. And then have another block which starts off with admin. And we were like, yeah, cool, 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 no doubt. But the thing is, we can't actually use equals. We can't bring an equals to the party. You know, if we do this, it's going the URL encoding is going to break us, which is, you know, the challenge. So we're like, okay, so that's off the table. We can't do that. But we can do things like just have a block that has admin, and then we were like, oh, we've got to have some padding here. So it's going to be like hex B, hex B, hex B, like all the PKCS padding. We're like, sweet, no doubt. And then we'll just basically have role equals butt up against the end of a block here. Now it looks about right. And then we're going to take this and do a reordering and put this here. And we'll cut and paste the previous block to have and role equals, and then yep, cool, no doubt that's going to work. And that's actually the attack we did do, and it was made possible by the fact that we can bring all these Bs to the party, because we thought we would need to kind of terminate this block using PKCS 7 padding, but the encoding function encodes hexobs, boo, wasn't going to work. And I was editing and I was like, I don't need to bring all these Bs to the party. What if we just let them be ampersand uid equals 10 and role equals user? We can just grab that block there. Right? we don't need all the hex Bs because this ampersand effectively acts as a truncator. Like, what's wrong with just copy pasting that block? Kind of like this. Slide you along and have the ampersand roll equals. And we're good, right? There's going to be duplicate UID equals 10, but that's all right. Our parsing code that takes a query string to a dictionary, it just kind of, I think, takes the first or the last, I can't quite remember, but it handles duplicates without complaint. And this roll equals user. Let's append a pipe. This is becoming a bit hard to see, but that's going to basically truncate here, I think. And we're good. We didn't need to bring a whole bunch of hex Bs to the party. We can just let this be this trailing garbage tidy things up for us. And then what I did was I jumped into Python 4. Look at me living in the future. And where's our query string stuff? URL encode, that's the one we want. I'm just going to yoink you, paste you. No, parse QSL over something like this with a little roll hanging out at the end there doing nothing. The Python just sees ampersand roll and it's like, oh, that's a key but no value, I'll just ignore it. So we get a garbage email address, but the important part is roll equals admin and we win. So this should be doable. So let's see if we can. First of all, we'll write a test case for the hard pattern. Yank 3 down. No, that's not what... Yes, it is what we want. So we'll yank those, put... hang on, our oracle needs to also act in hard mode. Yeah. So the oracle can take a hard mode boolean, which is false by default. Give it a property. Set the property. Cool. Now it's our email to QS that takes the hard mode. So here, hard mode equals self.hardmode. Good. And if we can get this to work, by the way, what I plan to do is take out all these hard modes and just make this hard by default. We can tidy up all our old code once we prove that we can exploit the hard case. So let's comment out this test for now, make sure all of our tests pass, we haven't just broken anything. Okay, test pass. Uncomment that. So the oracle is going to be hard mode equals true. And now the tests should fail. There we go. Yep, it's actually our PKCS 7 that's complaining because all of these hex OBs turned into percent OBs, and our unpatter is like our bad padding. Cool. So now our job is to let's see if we can make this work. You know, I'm going to comment out the easy mode test case. Let's just focus on getting this test to pass. And I added a unhappy path test case here. Let's also comment that one out because I think we're going to have to rethink this guardrail as well. So we'll comment that out. Okay. So B1 is a whole bunch of spaces that basically take us out to the start of the next block. B2 is going to be roll, and we don't want to add on all of this padding. We just kind of don't want it anymore. The ciphertext is encrypt those two concatenated. Fine. So the block that says admin is going to be block 1. That's also fine. For padding len, what are we doing here? here we are making sure that roll equals ends on a block boundary, so that should still be fine. I'm getting yelled at because that might be referenced before assignment, which is false. Go away, linter. The winning ciphertext is everything but the last block of CT. Hang on. Oh no, CT's here. Which is just oracle over that to the padding length. So okay, yep, cool. So the winning CT is basically chop off that last block that used to just say user and then tack on our admin block. I've got a feeling that's all we had to do is comment out all this stuff here because we never needed it. Do the test pass. Nope. Bad padding. Because of course, per PKCS 7 padding, because this here, this plain text is perfectly block aligned, PKCS 7 always needs a full block of hex 10. You always have to pad, even if you're at a multiple of the block size. Okay, so we should be able to manufacture a block of hex 10. We should be able to manufacture that. How are we going to do it? Okay. Build a block that just says roll. No, it doesn't just say roll. Build a block that starts with the given roll and ends with ampersand viewed equals 10 and roll ish. We might have to think about what are the limitations on the length of the given roll. Death Pimps says, hey, you're my favorite hacker. Welcome, Death Pimps. Hope you enjoy the stream. Death Pimps, I think I know you. I think I know who you are. Yeah, that ish. We have to think about the length that the roll can be, but we'll come back to that. So we're going to build that. That's all good. We can delete this once everything starts working. The next thing we want to do is build a block of all padding. And how we're going to do that is base ciphertext equals the oracle over empty string. Death Pimp says, haha, no I don't. Okay, I've got a friend who goes by the name Pimp, so I thought it might have been them. So the base ciphertext is oracle over empty string, and then basically while true, I can reuse CT because we're going to redeclare it down here. That's fine. This doesn't depend on CT. No, we're good. So while true, CT is going to be oracle. No. For I in edit tools, Pimps is trolling. I don't know who's who anymore. You all can figure it out among yourselves. Yeah, it's you, Pimps. I know it's you. So edit tools.count. We'll start counting from 1 forever. CT is going to be the oracle over space times I. We're basically going to ask the oracle to keep encrypting stuff until a whole extra chunk appears at the end. And in that case, it's going to be a full chunk of padding. So if the length of the base ciphertext is not equal to the length of ciphertext, we know we've just tacked on a whole new block. Block of all padding is going to be list over chunkify over CT chunked to the block size. Grab the last one. How did I mess that up? And then break. And then here, what are we doing? we are ensuring that a block ends with man, I calculated that in a weird way, but it works. It's not dumb if it works. I could have just used math, but instead I loop and count and try until it works. Goodness gracious. Ensuring that a block ends with roll equals. Find a padding len such that a block ends with roll equals. Good. Get a ciphertext of just a padding len. Good. Chop the last one of the ciphertext of that off. That's good. Append the block admin and append our padding, right? Blockable padding. Nope. Now do the tests pass? Hard mode done. It was not as difficult as we made it out to be last stream. So we can get rid of the padding we were trying to bring to the party. We can... Let's back out that hard mode stuff. We don't need the switch anymore. So get rid of the hard mode parameter. Get rid of the conditional. Good. The oracle does not need a hard mode anymore. Get rid of that. Get rid of that. Get rid of that. Get rid of this test. Just start using the old test. Get rid of that, get rid of that, get rid of that. Uncomment this. Run main. Cool. ECB cut and paste the hard way was possible after all. I'm really glad that I could get to the bottom of that because, yeah, as I said, during editing I was like, surely it's still exploitable. Now, one thing I do want to do is think about, because this craft profile CT, right, we're allowing the user to specify the role that they want to be cut and pasted into place. The challenge only asks that we make this work for the string admin, but we've made it work for arbitrary strings, but I don't know it's going to work for strings of all length. Menstrual, thank you for the bits, my friend. Much appreciated. Can see you're all making use of the new toys we've got. Death Pims. Are we doing ECB suffix brute force? No, we're currently working on ECB cut and paste. Well, we're just tweaking the ECB cut and paste we did from last stream. So given an ECB encrypting oracle that takes an email, slams it into a URL query string, and then ECB encrypts it, we want to, so we only control this bit here. We can't use ampersands to break out of this part here. We wanted to do ECB cut and paste to produce a ciphertext that has role equals admin in it. So that's what we're just tidying up from last stream. And we're almost done and we can then move on to some fresh stuff. I just wanted to get this out of the way. Here's the lazy way of finding out what the length limitations are on our attack. For I in range 24, print I and print roll's going to be Z times I. Print I. Roll 2 is going to be crafted profile ciphertext over, no, profile is going to be that over oracle equals oracle.encrypt, and the role is going to be roll yoink these two lines, and then print. This is going to be roll 2. I'm just going to brute force the limitations of the attack we've written. Print roll is equal to roll 2. And then run main. Okay. What's going on there? What's this? Use USU? What? Okay, yeah, no, that's fine. So we get false, 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 false. So as soon as the roll is 3 characters, our attack works, and it stops working at 17. Yeah. So get a load of this bullshit. If 3, no. If not 3 is less than that, is less than 17, complain. Hard coding in the limitations, but that's all right. It only needed to work for the role admin anyway. So for that, then here we're going to try accept value error. We've got an error. Run this. So yeah, we appropriately got given an error for all of these. And then we get true, 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 true. Got an error. Cool. If we decrease this by 1 and increase that by 1, does the falses start leaking in? Didn't leak in there. Leaked in at the top. So 17 was the correct number here. This is awful. Reduce this by 1. Do we start getting falses leaking in now? Yes, we did. We've just brute forced the limitations of our attack. And we can now... Hang on, what error are we raising? Roll must have a certain length or the attack fails. YOLO. Reef BR, thank you so much for the bits, my friend. Appreciated. I've been ignoring chat, I'm sorry. Reef BR remembers Menstrual CTF from a few years ago. Yeah, Menstrual makes some killer challenges. Men's, yes, you should create more CTFs. You do a good job. My streams are gold. Thank you so much, Reef BR. Appreciate it. Yeah, so my stack is a bit different these days. I'm doing things inside a VM, inside a container, inside a VM. Turtles all the way down, so definitely shouldn't have any of my private stuff leak into the streams. But never say never, right? Keep your eyes peeled, you might see something nifty. So given like 2 Zs, we should get an error. And given like 20 Zs, we should also get an error. So I've just got some test cases here to make sure we're stopping the caller from calling us with something that our solution doesn't solve for. Run those tests. Gonna get rid of this. Oh no, we'll leave it in there. So for ZZ, this is the error we expect to get. Drop that there. And for a whole bunch of Zs. Ooh. We've got another test failing. We'll come look at that in a minute. This is one. This is the error string for the whole bunch of Zs. Grab that. No. What have I done? Gotta grab this one. Atwolf coming in with the sub. Thank you so much, my friend. I appreciate your support. Okay, where are my tests failing now? Aha. That's the one we had to fix up. Paste. Okay, good. So now we just got this error here. And that test is failing because we're working in hard mode by default now. And so this should be %40. And so should this one, %40. And I'm still getting yelled at. Why am I getting yelled at? That %OB should not be leaking in. That should, sorry, the hex OB shouldn't be there. It should be %OB. Rerun the tests. Oh, come on, what now? Expected that, got that. How are they different? Oh, I've got a errant B there. Run the tests. Don't you just love like fixing your tests until they pass? Okay, now we're good. Now we're good. Cool. Well, that's how to do ECB cut and paste the hard way. So I'm happy with that. It was bugging me, and I'm glad we could resolve that. I'm going to take a quick 2-minute breather. I suggest you do the same. Grab yourselves a glass of water, stretch your legs, and we'll be back on the other side of a short break to tackle... What are we tackling? PKCS 7 padding validation. I think I already did that. I think I kind of accidentally built that in when we did our padding implementation. So if we've already done that, we'll be working on CBC Bitflipping Attacks, which sounds pretty cool. Anyway, I'll be back in a moment. Grab yourself a glass of water, and I'll see you soon. Alrighty, we are back. And as I was taking a break right then, it kind of hit me and sunk in that I'm really appreciative that people are showing you their support with subs and bits. Like, so what happened was, with all the streams we've been doing lately, I made the eligibility requirements to have the sub button turned on. I turned it on kind of YOLO, thinking if people use it, sweet. If people don't, I kind of don't care. It's fine. I don't get me wrong, completely appreciate the people who are subbing, but it just kind of hit me that that you folks are wanting to show you support like that. Had a bit of a moment, and I really appreciate it. And I'd be doing this for free. I've done this for free on and off, mostly off for years, and I'd be doing it for free if I couldn't be paid or anything like that. So don't get me wrong, there's no pressure to sub, but for those who have, I really, really appreciate it. Makes me feel warm in the heart. And I had someone ping me as well to be like, what's the deal with the ads? So I just wanted to quickly kind of clarify why I'm showing ads during the breaks. I don't have to. I can not show those little ad breaks. But basically every time I do, Twitch turns off the ads that people see when they join the stream for 30 minutes. So every time I take a break and run a couple of those ads for the people who would just be staring at the BRB screen anyway, Twitch basically turns off what's called pre-roll ads, turns off the ads as people join. So while I'm BRB, may as well chuck up a couple ads to not have people then have to wait before they enter the stream for the next 30 minutes. So that's the reasoning there. I don't have to show those ads, but it just makes getting into the stream for newcomers a bit quicker. So anyway, TLDR, thank you so much. I really appreciate the support. At Wolf, I do need more custom emotes. I did the Justin Love real quickly yesterday in the GIMP. Then I started trying to draw a calculator, and I was like, wait. Heart, not so difficult. Calculator, super difficult. So I may have to find someone to do some art for me. Paid, of course, I'd be paying for it. So I do need to flesh out the emotes, but they will come as they come. They'll come organically. I don't want to crank out rubbishy ones. I want them to be on brand for me as they arrive. So once I find how to get someone to draw a good calculator for me, we'll have a calculator emote. Men's, what beer am I going to be trying today? I've got some non-alcoholics in the fridge, so I'm a little bit dusty, as Menstrual has forced me to admit. So I may crack open a non-alcoholic later. We'll see. PKCS 7 padding validation. Let's have a look. Write a function that takes a plain text, determines if it has valid PKCS 7 padding, and strips the padding off. So Ice Ice Baby with 4 4s returns Ice Ice Baby. Ice Ice Baby with 4 5s does not have valid padding, nor does Ice Ice Baby 1 2 3 4. Because the unpad is going to see the 5 and check to make sure that the last 5 bytes are 5. Because there's a Y there, it will error.
This one here, Ice Ice Baby with a 4, we'll check that the last 4 bytes are 4, and because it's got a 1, a 2, and a 3, it does not and will error. If you're writing in a language with exceptions, make your function throw an exception. Crypto nerds know where we're going with this. Bear with us. I am by no means a crypto nerd, but I saw around that corner. Our padding function already complains about invalid padding. Where are we? PKCS, unpad there. So I saw around this corner and had my unpadder have a parameter strict, which defaults to true, and if it's strict, we're already doing that checking that the challenge wants us to do. And if there's bad padding, we raise an error. And I've already got a test case for it too, right? Hello world with 2 2s, fine. But hello world with a 2 raises a padding error. Look at me go, I even created a proper exception class. So we are done. Set 2 challenge 15 can get out of here. Men's non-alcoholics are really good now. Yeah, man, I'm trying. What is it? I think it's the Quiet XPA. I've got one left. Yeah, the Heaps Normal Quiet XPA. I mean, they're not cheap for what's essentially a soft drink, right? But they're really good. Like you can tell they've got a little something in the background missing. The flavor's not quite, full-bodied, high-alcohol XPA, but they taste damn good for non-alcoholic. So I'm really, really impressed with the Aussie breweries that are doing non-alcoholic options. They're knocking it out of the park right now. CBC Bitflipping Attacks. Create a random AES key. We can do that. Combine your padding code and CBC. So I'm guessing it's suggesting we need to use strict PKCS 7 padding. Write 2 functions. The first function should take an arbitrary input string and prepend comment 1 equals cooking MCs semicolon user data equals. And it should append the string semicolon comment 2 equals like a pound of bacon. So we need to sandwich the attacker data between these 2 strings. The function should not allow the attacker to bring semicolon and equals to the party. Okay. The function should then pad out the input to the 16-byte AES block length and encrypt it with the random key using CBC, I'm guessing. Our CBC encryptor already does padding, so we get that for free. The second function should decrypt the string and look for the characters semicolon admin equals true semicolon, or equivalently, decrypt split on semicolon, convert each resulting string into 2 tuples and look for the admin tuple. Okay. Return true or false based on whether admin equals true or false. So return admin, basically. If you've written the first function properly, it should not be possible to provide user input that will generate the string the second function is looking for. Correct, because we're going to be killing these characters. We have to break the crypto. Instead, modify the ciphertext without knowing the AES key to accomplish this. You'll be relying on the fact that in CBC mode, a 1-bit error in a ciphertext block completely scrambles the block the error occurs in, produces the identical 1-bit error in the next ciphertext block. Before you implement this, answer this question. Why does CBC have this property? It's because of like the wormy pattern, right? Wiki block cipher. Anyways, we should just bookmark this page. Come on, add a bookmark. There we go. Where's my CBC? Here it is. In CBC, a 1-bit error in a ciphertext block completely scrambles that block, but produces the identical 1-bit error in the next. It's because in decryption, if you flipped a bit in here somewhere, this AES cipher is going to completely junk up this plaintext block. Even a 1-bit error going into here is going to catastrophically change the output. But that 1 bit that you flip in here
if we follow this line, it causes a bit flip post decryption for this block. So this block will decrypt nicely, but then we can spike bits at a time. Detox Mango, hey, what do you think about hacking into a crypto exchange and creating a server with better latency? Those sound like two very different things. The first one sounds like a crime, so I don't think I want to do the crime. And what do I think about creating a server with better latency? Is it possible? Yeah, you can always create servers with better latency, but I'm not sure what that's got to do with the crime at the start of the question. So sorry Detox Mango, I will not be able to help with your crimes. Okay, let's grab this challenge text here. Set to challenge 16, CBC Bitflipping Attacks. Set to challenge 16, CBC Bitflipping Attacks. Oops, just added that to Git. Ah well. Let's do the boilerplate. Drop in our challenge text. Create an empty main. If name equals main, run main. Alrighty. So we start off with the whole generate random AES key, and then create a encrypt oracle and a decrypt and parse function. I'm really sorry, I'm just struggling to read your name here due to the colors on my screen. Zayas1, I'm sorry if I'm saying that wrong. What happened to Python? We're still using Python. Python's still good. It's just a little airborne. So I'm just going to call this class Oracle for now. We might think of a better name shortly. It's going to have a key which is bytes. And upon initialization... Detox, would it be a crime if I find a test server with better latency for trading? One of my mods spiked that message. Detox Mango, I'm not the right person to ask about what's a crime. I can definitely tell you hacking into crypto exchanges is a crime. For other things, I suggest you consult with your lawyer, perhaps. I don't know. Yeah, thank you for whoever cleaned that up. Detox, let's not talk about hacking crypto exchanges and doing crimes here. That's not what we're about, unfortunately. I'm not going to even say unfortunately. It's not what we're about. Okay, so upon initializing this oracle, from secrets, we're going to pull in our token bytes. Good. We need a block size. Good. Self.key is going to be token bytes to the block size, so we generate that random key. Good. Encrypt should prepend this. Prepend this, append that, and encrypt under CBC. Cool. Let's pull in from util, import our CBC encrypt and CBC decrypt. Good. So our oracle is going to have a encrypt self user data. It's going to be, I'm going to let it be bytes. What's this attack called? We're doing CBC Bitflipping Attacks right now. Encrypt. I'm going to copy this to give us something to work with. What a mess. So data is going to be... So the prefix will be that as bytes. The suffix will be this as bytes. The data is going to be prefix plus the user data coming into this function plus the suffix. But
the user data is a value with a key of user data. We just need to basically make sure that the attacker's not bringing special characters to the party, which raises the question again. Do we want to again do a hard mode and URL encode anything that's not URL safe? Because we can see that like spaces are becoming %20 here. But again, is that just going to make life hard for us? And then are we going to decide it can't be done? And then during editing, will I see how to do it? Decisions. How are we going to clean up the user data? Men's said plus would become a problem. We're doing bit flipping against CBC. Hard mode shouldn't be a problem. Famous last words, am I right? Is URL encode what I want? No. Python URL lib parse. Let's do the hard mode. What function do we need? Quote, that sounds right. URL lib parse quote. Pull in quote. So quote over A gives A. Quote over space gives %20. And quote over, does quote take bytes? Quote over hex OB gives %OB. The semicolon and the equals, do they both get spiked? They do. This feels like the function that's just going to like kill any characters that are non-URL safe. If we do quote over bytes of range up to 128. Yep. Control characters, control characters, control characters, control characters, control characters. Dash dot slash numbers, control characters. Alpha, control characters underscore alpha. Yep, and the tilde. We get the tilde as well. I think we can make this work. From URL lib, import quote. Weird function name, but alright. Let's just quote the user data here. Now I kind of want to test this in isolation. We don't need this for text anymore. Yeah, you know what? Let's return data. And this is not an encrypt function. This is actually a sandwich. Create the sandwich. And it's a class method because it doesn't need self. We can now write a test for this in isolation. Why are you squiggly? Oh wait, it's not a class method, it's a static method. That's better. Yeah, we can now test this in isolation. Actually, this prefix and suffix, we could make it parameterizable for the class, but let's just leave it hard-coded. So now if we do the oracle dot sandwich over bytes, needs to be AAAA, we should get back, oops, let's just tidy this data up. And there should be 4 A's in the middle here. Good, 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 good. So does that test pass? I've screwed something up. Oh, URL lib.parse has quote, right? Good. Can't concatenate string with bytes. Because quote returns... Okay, so quote returns string. Yeah, so this is allowed to return string, actually. That can return string. Get rid of that, and get rid of this B. Takes bytes, returns string. That should be okay. Yep, tests passed. Now, the main thing we want is this sandwich function to not allow semicolon foo equals bar to work. So if we run the tests, we get back user data equals 4a's, %3b foo, %3d bar semicolon. That looks like what we want it to do to protect itself from key value injection. Steal that, whack it into our tests, run the tests, and we should be good. Alright, sandwich function is done. We still need an encrypt function. So encrypt is going to take user data, which is bytes, and we're going to have plain text equals self.sandwich over the user data, and PT is then going to be string, so we need to encode it to get bytes so we can encrypt it, and then we return hang on, CBC, we need an IV, don't we? I was going to say we're going to return CBC encrypt with plain text equals PT, which is bytes at this stage. Key is self.key. IV equals... We need an IV. Did the challenge tell us to generate one? Generate a random AES key, done. Pad it. Our encryptor handles padding. Encrypt it with the random AES key. Fine. I can't see this telling us what to do with IVs. And so... actually, you know what? CBC encrypt. Let's have a look. Come on, zoom in on it. There we go. IV is bytes. Does this function return the IV? No, it just uses it to initialize the first previous block and then doesn't return it. Okay. This encryption function can generate a random IV per encryption. I think that's acceptable for the Oracle to do. So the IV is going to be token bytes over block size. The ciphertext is going to be... Whoops. There we go. Drop the IV in there. And then we're going to return the IV plus the ciphertext. Traditionally, when you're doing block mode cipher encryption, IVs aren't secret. The key's obviously secret, but the IV is public knowledge. A lot of implementations of CBC encryption, or any IV-based encryption, just tack on the IV to the beginning of the ciphertext. So that's what we're going to do here. We're going to return the IV concatenated with the ciphertext. So the encrypt is done. So now we've got the decrypt, which takes ciphertext, which is bytes, and it's going to return, I think the decrypt should just return basically the value of the admin. And I'm going to return a bool as to whether admin was case sensitively TRUE. So this decrypt returns a bool. I should probably document my decision there.
fact, I should document encrypt. And I should document the oracle. Everyone gets documentation. So the oracle, we'll fill that documentation in last. Encrypt. Take some user data, sandwich it into the challenger's specified format, encrypt with the oracle's key and a random IV, return IV concatenated with ciphertext. Good. Decrypt. Take a ciphertext, which is actually IV concatenated with ciphertext, decrypt it with the oracle's key, encrypt with the oracle's key, encrypt using AES 128 CBC, decrypt it using AES 128 CBC with the oracle's key. Yep. Fix the typo. Take a ciphertext, decrypt it, parse it, and return true if the plain text's role is precisely true, else return false. Okay, that's what we're aiming to do. So we're going to go PT equals CBC decrypt with the ciphertext. Yuck. CT chunks is going to be chunkify, which we don't have. Pull it in. I'm going to chunkify the ciphertext to block size. IV CT is going to be the chunks. Oops, we need to list this. So the IV is going to be CT chunks 0. Why are you angry? Need more values. I'm not done yet. And the ciphertext is going to be empty bytes dot join over CT chunks from 1 onwards. So we kind of break off the first chunk, it's the IV, and the rest is the ciphertext. So the plaintext is going to be decryption over the ciphertext equals CT. What's the next parameter? Key is self.key, and the IV equals the IV. Now we need to parse it. How are we going to parse this semicolon delimited mess? Does URL-lib give us something to work with? Let's have a quick look. Aha! Parse QS and parse QSL, which we... They both have separator equals ampersand. We can just override that to be separator equals semicolon, and that's how parser written, right? What did the challenge want? We're going to decrypt it, split on semicolon, convert into 2 tuples, and look for admin. We should be able to do this. Let's parse the QSL. We'll pull in the parse QSL. Data equals parse. No, it's going to be dict over parse QSL over the plain text, with the separator being semicolon. And then return data
admin is precisely equal to true, lowercase true. Why are you yelling at me? Expected bytes got string. Alright then, I'll give you bytes. I can give you bytes. Now, do we need to break this apart to make it testable in any way? Nah. But we do need a YOLO test of just encrypt, decrypt, make sure we get back false. I probably should have better tests than this. Do I want to break this up and test it properly? No, I don't. We just want to assert that we've got Oracle is an Oracle. Then we want Oracle.encrypt with the user data being bytes of just AAAA. If we wrap that with Oracle.decrypt, we expect to get back false. Because Oracle.encrypt with a bunch of A's and then you decrypt it, the admin value won't be true. So we run the tests. The test fails. How about that? Exception raised. There was no key called admin. Really? I'm going to set a breakpoint on you and try you again. Oh, wait. Hold up. Hold up. Where's our sandwich? There is no admin equals in here. You don't get one for free. Okay. Alrighty. All good. All good. Let's stop this debug. Let's do admin equals that, and then return admin is exactly equal to true. But we need to wrap this with a try and accept a key error. No admin key. Return false. Can't type. Okay, so now we're at least catching the case in which admin doesn't exist as a key, which we should have thought to do, to be honest. Run the tests. Test run clean. I kind of want to set that breakpoint again, actually. Let's just have a quick squeeze at this and make sure it looks reasonable. You know what? That breakpoint will never hit because we're ending up here. So cheeky breakpoint in the right spot. Okay, decrypt. Ciphertext looks like it was random noise because the input to this, this decrypt is actually the output of Oracle.encrypt, so that's noise, that's fine. We separated the CT and the IV, that looks good. We then did PT equals, and PT is bytes. Comment 1 equals cooking MCs, user data is 4A's, semicolon, comment 2 looks good to me. And then data, we parsed it into a dictionary. We got the comment 1, the user data, the comment 2. And we tried to pluck out admin from that. Failed. Return false. Kind of a shitty test, but I'm happy looking at this in the debugger. It looks sensible to me. Is that our Oracle written? Are we done? Generate the key, done. Our padding code is being used by our CBC code anyway in a strict mode. We're doing the sandwiching. we're successfully blocking the use of semicolon and equals. Good. Our CBC function does the padding for us. We are encrypting under the random AES key and a random IV and then packing them together as the ciphertext. That's the encrypt function. The decrypt function should decrypt it. We're doing that. Look for admin equals true or equivalently decrypt, split, convert into tuples, and look for the admin tuple. We're doing that in a bit of a roundabout way. Return true or false based on whether admin is true. We're doing that. Now, if we've written the first function properly with blocking of these two characters, it should not be possible to get the oracle to give us something which we then decrypt to have admin equals true. We've got to break the crypto. Understandable. Okay, so now we need to modify the ciphertext without knowing the key. And we're relying sudo kevinaf. I see that'll be with you in a moment. We're relying on the fact that in CBC mode, a 1-bit error in a ciphertext block completely scrambles, produces. Yep, good. We kind of... Okay, so this is the part we've got to digest. Kevin, were we on challenge 13? Yes, we were. So, challenge 13 was actually me revisiting last stream when I built something I thought was unbreakable, but turns out to be breakable. 14 we actually did last stream. 15 was super easy. It was basically saying make your PKCS 7 padder, or more precisely your unpadder, strict. And because I'm a perfectionist jerk, I had already done that. So my PKCS 7 unpadder was always being strict by default. And in the case of bad padding, it was always raising errors. So this was a no-op for us, we'd already done it. And so now we are on 16, the Bitflipping Attacks. So I hope that clues you in, and I hope your dinner was delicious. Alrighty, I'm going to take a quick break for a couple of minutes to grab some water. I suggest you do the same. And when we get back, we're going to be bitflipping some CBCs apparently. So I'll catch you on the other side of a short break. Alrighty, we are back. I've got myself my fizzy drink, try and settle my stomach. The old, what is it called again? Heaps normal, quiet XPA, 0% or 0.5% or something XPA. They're delicious. A bit of a non-alcoholic hair of the dog. Alrighty, so we're working on CBC Bitflipping. So what I think I want to do is have our oracle optionally work in a debug mode so we can get some insight into what's going on the inside. Oh, we need to document this oracle, don't we? We need to name it something better than oracle as well. What is this? What is this oracle actually doing? Sandwich oracle. Not a good name, but at least it makes me laugh. Let's not bother documenting it. Documentation's for weenies anyway. But we do want the oracle to take a verbose bool is false by default, and we'll have a verbose flag. Self.verbose is verbose. So during the encrypt, we want to if self.verbose print user data bang R turned into PT bang R, which turned into IV and ciphertext bang R. And then for decrypt, what do we want to do about decrypt? Here is just fine. If self.verbose print ciphertext bang R. Yeah, we'll print the whole lot, why not? Turned into plain text bang R, which turned into data. We don't need to bang R the dict, it will be pretty printed for us. Sandwiching, we don't need debug stuff there. It's a static method anyway, it won't know if it's in debug mode or not. So for main, we want to do ciphertext, we need to do an oracle first. The sandwich oracle with verbose is true. The ciphertext is going to be oracle.encrypt with a user data of AAAA, BBBB. It's got to be bytes. And then we want to oracle.decrypt the ciphertext. Run that. And we get some insight into how the oracle operates. So our A's and our B's got sandwiched and produced ciphertext. You know what? I'm going to switch up this ciphertext. It's too long. Let's do ciphertext. Let's do the first 5 bytes and hope that that's not giving us too little visibility. Just because binary noise is kind of a bit of an eyesore. And again here, the IV and the ciphertext will again just get the first 5 bytes. ... And rerun. It's a bit nicer. So the A's and the B's got sandwiched. And then our ciphertext turned back into this with the sandwiching, which got unpacked into a dictionary with the user data being A's and B's. And of course, it is not going to be as simple as doing this. Semicolon, admin equals true. If we run this, the admin equals true, URL encoding happens, ruining our plan of just naively injecting a new key pair. And during the decrypt, you can see here it's all encoded. And then the user data ends up being literally semicolon admin equals true. Boo. So we need to bitflip our way to success with an admin equals true turning up somewhere. And because our unpatter is strict, we cannot afford to break the last block, or we'll get a padding error. Let's have a think. Let's have a look at the block diagram of CBC decryption and think about how we can do this. Because if we flip a bit here in the first block's ciphertext, or even if we flip a bit in the IV, oh, flipping bits in the IV, that's perfect. Right? Because if we were to flip bits in the actual ciphertext block, it's going to catastrophically destroy the output of this here. And then a flipped bit is going to influence this block here. And that's where the breakage will stop, because this feed forward is not influenced by the flipped bit here. So if we flip a bit here, we get catastrophic destruction here, but we get bit by bit XOR control and flip bits into this plain text block. But if we flip bits in the IV, like, what am I missing here? Why is that not the way to do it? Let's just have a play. Let's have a play with both those scenarios. So let's get ciphertext for, let's go back to our AAAA, BBBB. So that's our ciphertext. Now, let's steal some code. Let's chunkify and then grab the IV and the ciphertext. This here needs to be CT. So the oracle is a sandwich oracle. We're going to encrypt the A's and the B's. And then we're basically going to snap off the first block, which is the IV, and then leave the rest of the blocks as CT. And in here, we would need to decrypt the IV plus the CT, because we snap the IV off. We run this,
Still behaves perfectly fine. But then if we IV equals, how do we want to do this? If we do IV equals IV0 plus IV, the rest of the fucking IV, you can't concatenate int and bytes. Okay, so I think we need to perhaps do it like this. So we build a list, because when you start slicing bytes, weird stuff happens in Python. So if we just do A is ABCD. If we go A0, we get int. If we go A from 1 onwards, we get bytes. Thanks, I hate it. So, I actually don't like this. We can do bytes over list of IV0 plus IV from 1 onwards. Yuck, but it should work. There we go. Now this IV0 here, if we XOR that with 1 to just flip the lowest bit in it, then the comment 1 equals cooking MCs turns into bombent 1 equals cooking MCs, and none of the rest gets damaged. So we can just bit flip the IV to have this first block here contain admin equals true, as opposed to let's just wholesale duplicate that whole block of stuff so we don't have to worry about overwriting or having stuff being overwritten. If we try this again, we snap the IV and the CT off. Instead of this here, we'll do the CT is the bytes of, you know what, we can just do this. Yeah. If we just flip the first yeah, if we get the ciphertext and get the first byte of the ciphertext and flip the lowest bit in the first byte of the ciphertext, going back here, I expect if we flip a bit in the first block of the ciphertext as opposed to the IV, this is going to catastrophically blow up, and we're going to be able to flip a bit in the second block of plain text. Yeah. It blew up even worse than I was expecting. It blew up in here. Let's set a breakpoint on that and debug. The first time through was fine, we continue. It's the second time through. Because plain text, it's kind of hard to read. Yeah, see that first block of the plain text got catastrophically destroyed. And now parse QSL is blowing up when it tries to actually use this because it's not valid Unicode. Whereas the, hang on, let's do PT up to 16, the first block. First block got catastrophically destroyed. So now we go from 16 onwards, and we can see we've got $20 MCs, whereas it used to be %20 MCs. So we were able to influence a bit in the second block of the plain text by targeting this bit here, but it caused this to just blow right up. So flipping bits in the IV seems to be the cleanest way to do it. Like, tell me I'm wrong. Let's make it happen. Don't need you anymore. We need to lift this into a function. Craft CT
What was this function called? Craft CT with chosen PT prefix. This is essentially what we're doing by messing with the IV. And it takes an oracle, which is a callable, over. It takes bytes and it gives bytes. Pretty sure this is going to return bytes because it's returning ciphertext. Pull that name in. So the oracle is going to be that, and then we're going to craft. We're going to go CT equals craft the CT with the chosen PT prefix. Oracle equals oracle.encrypt. We need another parameter. Prefix is going to be bytes. And the prefix needs to end up being admin equals true semicolon. Is that less than a block in length? Yeah. 5, 9, 10, 11. Yeah, so the first thing that this function needs to do is if the length of the prefix is greater than the block size, raise a value error because we can't. Our attack, if we just mess with the IV, can't deal with that. The prefix is too long. Why are you yelling at me? Why are you yelling at me? Oh, because it needs to be bytes. There we go. Get rid of all... Actually, you know what? Let's not get rid of that. I'm gonna... Yep, get rid of that. I'm gonna borrow this. Delete 4 down here. Let's stash you up here. So main is then going to print oracle.decrypt. No. Is admin is going to be oracle.decrypt over our crafted ciphertext, and then print are we admin is admin. Cool. Typo. Now just for giggles, oh yeah, we just need in this function we need some ciphertext. This is going to be the oracle over empty string. Should be fine, I think. Let's just return the CT. Return the CT for giggles, because this should give us are we admin false. So if we run main, are we admin false? Oh, now Oracle's acting in verbose mode, which is fine. We'll leave that there for now. Cool. So we chunkify the ciphertext. We snap off the IV and then leave the CT. And in the IV, we're flipping the lowest bit. Here's the bit where we need to intelligently flip those bits. And then at the very end, we need to return the IV plus the ciphertext. Yeah. So here's where we need to bit flip our chosen prefix into the IV. This function really needs 2 callables. It needs an encrypt oracle, which is the callable over bytes giving bytes. It also needs a decrypt oracle. The reason for that will hopefully become apparent in a moment. Decrypt oracle is a callable over bytes, which gives bytes. And down here, we need to give it the decrypt oracle. Is oracle.decrypt. Why are you yelling? Okay, so that decrypt oracle is not actually a decrypt oracle. We need to fix that. It can't return bool. It still needs to return bytes.
Really, this function here is decrypt and parse. Yeah, so we need a new... how am I going to do this? I'm going to rename this here to decrypt and parse. Because really what it's doing is it's taking the ciphertext, decrypting it, parsing it, and returning the admin. Or the role part, yeah. Right, it's not looking for the plaintext role, it's looking for the plaintext's admin. So that's decrypt and parse. We need a new function which is just the decrypt. Which again takes the ciphertexts, which is bytes, and returns bool. Yoink those lines, put them up here, and return the plaintext. And then down here, the plaintext equals self.decrypt over the ciphertext. So we've just kind of broken that function up a little bit to give us just raw decrypt. It's not returning bool, this is returning bytes. And now we can write a bit of a better test case. Let's just yoink those two. Instead of decrypt and parse, we'll just exercise the decrypt function. Run it. Whoops, no. Run the tests. And it will fail. Geez, we've got a lot of failures going on here. Profile oracle has no attribute decrypted. What? Oh my goodness, that refactor. Renaming decrypt to decrypt and parse also broke our profile oracle. Thanks, I hate it, PyCharm. Thanks, I absolutely hate it. What did we break? Hold on. No. ECB cut and paste. It's this one here. Profile oracle has a decrypt. Where have I gone and sprayed the token decrypt and parse? Okay, it looks like it's that line and that line. They should just be decrypt. Yeah, that was a very aggressive refactor on Python, on PyCharm's behalf. Rerun the tests. Okay, we unbroke that test, hopefully. Hopefully that's the extent of the damage we did. So this is fine. I was expecting this to fail. So I just wanted to go and pinch this for our test case. Yep. Okay, run the tests. Test pass. We basically teased the decryption stuff out of the decrypt and parse function. So now, the decryption oracle it can be oracle.decrypt. Excuse me, and our craft function now has access to both oracles. So now we come back to bit flipping our chosen prefix into the IV. The reason I wanted this function to have access to that decryption oracle is so that it can get the plain text of the first block of what the oracle produced as the ciphertext. So the plain text is going to be the decrypt oracle over the ciphertext, the IV plus the ciphertext. We just print PT, that should come back as pretty sensible. Run main. Yeah, that's it there, I think. So PT first block is going to be the list of chunkify over the plain text to the block size. Grab the first block. Good. We can now, for A, B in
itertools.zip longest. So we can zip that PT first block with our prefix. PT first block against the prefix. We can now XOR those two together, but we need to have zip longest needs a fill value of 0. Because prefix is probably going to be shorter than the first block, we want to 0 pad the prefix because we don't want to be XORing stuff in past where we need to. So let's start a new crafted IV, which is a list of integer, starting off as empty list. So for each of these two characters each of these 2 bytes coming off the zip, crafted IV, append, XOR them together. So that way, because our first block here is probably going to look like comment 1 equals cooking, or something like that, up to 16 bytes. We basically want to XOR into we want to get the ciphertext that came back from this, which we know corresponds. No, we want to get the IV that came back from encrypting this, which we know once you then decrypt comes out as this. We kind of want to mask or flip the bits of our chosen prefix over the top of the IV, which transform this into whatever we want, which is admin equals true. To do that, we need to pair up the bytes from each of that first block. Comment 1 equals cooking, it's IV, and our prefix, and just start flipping away. And then we want to return the crafted IV plus the ciphertext. So now I think we can do... Let's comment this out and save that for the end. Let's yank 2 down. Ciphertext. Let's just... Oops, what did I do? Instead of having that prefix there, let's have a prefix of AAAA, BBBB, CCCC. Okay, we're good. And now we do print oracle.decrypt the new ciphertext. Our crafted ciphertext, and it should start with a whole bunch of A's, B's, and C's. We run this. That's fine. This crafted IV, we just have to bytes it. Turn our list of integers into bytes. Take 2. And of course it does not work. How did we screw that up? What have we done? I'm going to set a breakpoint here. And I'm going to debug. So we've got the IV and bytes over the crafted IV. So IV is this. Bytes over the crafted IV. Looks like that. Oof. I was expecting this here, the ends to be the same. We've got something real weird going on. What did I zip together? PT, hang on, PT first block. What have I done? PT is the decrypt. No, I didn't. This should be the ciphertext first block, not the plain text first block. Goodness gracious, that was never going to work. Okay. Hang on, I've completely messed this up. What have I done? Was I only ever meant to zip, not zip longest, the plain text first block and the prefix to kind of calculate the bit difference between them, and then I zip longest to XOR that into the cipher, into the IV. Yeah, I was. Okay, cool. So zip longest, that was never the right thing to do. We don't need a fill value. We just have to zip over the shortest of... we don't need iter_tools anymore. Okay, so we zip over the shortest of these two, which is going to be the prefix. And we're not building a crafted IV anymore. We're building a bit mask. I don't feel like that's the best name, but it'll do. So we're building a bit mask, which is basically the bit difference between the first block of our plain text and the prefix. And then we need to basically distribute that bit mask over the IV. Cool. So the bit mask is a list of integer. That should be fine, actually. We can leave that as a list of integer. So now for A, B in iter_tools.zip longest over the bit mask and the IV, we distribute the bit mask through the IV with the fill value being 0. So now we bring back our crafted IV. And then we do crafted IV.append. Here we append A XOR B, which is basically XORing the bit mask with the IV. Yeah, good. And we don't return bytes of bit mask plus the ciphertext. This needs to be the crafted IV. Take away our breakpoint. Run main, and hopefully now we get some plain text that starts with the A's, the B's, and the C's. Whew, okay, we do. We get A's, B's, C's, and then we get junk. So now this prefix just needs to be admin equals true semicolon. Is that right? Admin equals true? Admin true, yeah. Run it again. And we've now bit flipped admin equals true into the plain text just by playing with the IV. And then hopefully Python, when it tries to parse the rest of this, doesn't blow up too much. Let's test that. Let's grab the plain text equals that. And then what are we doing? Parse QSL over the PT. And then we're doing dict over the top of that. And we get admin. Oh, oof, no. Our parse QSL needs to have a separator being semicolon. Yeah, we get admin true. And then, hang on, let's print PT. So we get admin true comes through in our parsing. And then we've got oking space MC semicolon, which just looks like it disappears. Didn't come out in here at all. We've got user data equals empty string. Looks like Python also didn't want to give us that empty string. Fine. And then comment 2, it comes through. I think we're done. And we find out if we're admin by asking the oracle to not just decrypt, but decrypt and parse this ciphertext. And we should get the fact that we are admin. Of course, it was not going to be that easy. What? Why are we not admin? If we set a breakpoint here and debug it. Data is a dictionary with admin being true. This here just needs to do an equality with bytes of true, because the values in this data dictionary will always be bytes. They'll never be strings. So that was never going to succeed. So we built ourselves an unwinnable challenge. If we rerun main, there we go. We are admin. Super cool challenge. Yeah. So what we had to do is we built an oracle that basically takes arbitrary user data, sandwiches it between these two, doesn't let the attacker bring equals or semicolon to the party, CBC encrypt it with a random key and a random IV, And then we built an attack against that oracle that basically just bit flips admin equals true into the IV. I think that's super neat. I think I'm going to call it a stream now. We haven't been going for that long, but I'm a little bit dusty from last night, so I think I'm done. But before we go, let's see if we can find someone to raid. All right, we've got Cyber Kaida. Hopefully I'm saying that correctly. Doing reverse engineering with Ghidra. Golang calling convention extension. Ooh, that does sound good. Because reverse engineering Golang is a huge pain in the butt. So let's pop into Cyber Kaida's stream and see what they're up to. Alright. So if you're in chat and you're willing to pop in and say hi to Cyber Kaida with me, join the raid. Otherwise, I hope if you stuck around to the end, you enjoyed this. We basically did ECB cut and paste the hard way, which I'm super happy with. We didn't need to do the pattern validation, it was already done. And we did CBC Bitflipping Attacks, and we've finished set 2, which is super exciting. So next stream, we'll move on to set 3, block and stream cyber cryptography. And that looks super exciting. So give me a follow on here on Twitch, and you'll get an email when I go live. Follow me on Twitter and Mastodon. I normally tweet and toot before I go live. And if you join the next stream, I will catch you then. Thanks for your support, everyone, and peace out for now.